Okay, this is going to be a build video so that you can learn how to build the body twisting walking robot. It's actually a very easy build. The printing takes more time and parts, but if you haven't already watched the video on it, basically you've got a robot that walks and the body can twist. Of course, flashing lights and adding sounds, those are all extra things that you can do if you want but don't have to do. So the very first thing you're going to want to do is we're going to want to make two leg foot assemblies, and basically as you can see, when they're built right, these wheels can turn freely this way, but as soon as there's any pressure applied to them, they lock, so they won't turn the other way. That allows the foot to move forward but lock in the reverse, so kind of a ratcheting sound, but locks this way. And in order to do this, both legs and feet on the robot are the same, but you do have a left side and a right side, and you do have the two wheels to print. And I'm using rubber grommets to put on the wheels as tires for grip. So these are the two parts. This would be the right side of the leg foot assembly, and this would be the left side. And as you can see, there's a slot where there's going to be an axle for the wheels to ride in. You'll notice how the slot is aiming in an upward position. That way the weight of the robot will tend to make the axle always want to creep to the front, and this finger will then lock. Here's one of the wheels. Will then lock into the little openings in the wheel when they get set in there. And when it's rolling to the back, it can roll off the rounded top of that and release. When I print the legs, the only place they print flat on the printer bed like this. The only place that I put supports is right here, where the axle is going to ride. You can put supports here if you want to because there's a level change, but your printer should be able to bridge all that. Shouldn't be necessary. And I did that with both of them. And to assemble them, for the axles, let's talk about that. I just took a nail and cut the head off and cut the pointed part off, and it just sits inside the wheel. It doesn't matter if the wheel turns on the nail or if it fits tight. It doesn't matter because the nail, the axle, if you will spin freely in the foot part. This particular nail seems to measure about 1.8 millimeters in diameter, if that helps you guys find a nail or makes any difference to you. But I start by putting both of the wheels into the leg part. So it's hopefully that's in camera, sitting like that. And I'm going to go ahead and apply my glue of choice. You can use whatever you want. I'm using the Weld-On number 16 because it's cheaper than 3D glue and works better than super glues. And just hit the thick places of the foot, like so. And then I realize this probably doesn't get caught on camera, but I'm just tipping the axles in from the one foot to the other, and once I've done that, I'm going to push the two parts together. However, it's fighting me. There we go. Best way to align is to turn the thing upside down and use a tabletop surface to hold that. And if you have clothespins, you could drop a couple clothespins on it to hold the very top. That way you can concentrate your efforts down here in the foot bottom part. Apply a little pressure, make sure everything is lined up evenly. You can also check at this point that your wheels do turn free in the back but lock when you push them to the front. And if I'd been thinking ahead, I'd had a rubber band or something here that I could wrap around that. Maybe I do, maybe I don't. Let's try this, because then we can move on to other parts of the build. I'm just going to put this rubber band around there to hold those parts together. So the next part you're going to want to build, or make sure you have printed, is this bottom part. This is the bottom of the body where we're going to mount the motor and the legs and the bearings and all that kind of stuff. You can use any of the TT type gear motors, dual axle gear motors. This is the faster one, the standard one, the 43-to-1. And these are the cams that you'll print. They're both identical, but when you put them on the shafts, you want to put them opposite each other. So if one's facing down, you want the other facing up, for example. Don't quite push them in all the way yet, but you can set this right down into the housing like that. And then I'm going to drop in a couple of screws to secure this. Like I say, here in America, a number 6x32 screw, a 632, which is a common screw, will work great to secure it. There's places for 4, but you don't need 4. And if you didn't have a screw, you could always just glue the motor in, use some hot melt glue or whatever kind of glue you like. Or if you had a metric bolt and nut, you could run it through there and bolt and nut it in. So now we've got that part done. You need to print these 2 bottom cap pieces. They print flat, no supports. By the way, this motor piece prints flat, no supports. And what's going to happen is we're going to place the leg feet assemblies in here, and then these caps, I'm going to put glue out on the outer part, on the inner part, and the outer part, and they're going to get glued on, and that's going to keep the leg feet assemblies part of this, but totally free to move. There's a gap in there, as you can see, where the leg foot assemblies can run. So what we're talking about, make sure you have both your feet aiming the same way. At this point it doesn't really matter what's front and what's back, as long as you do them both the same. Put one on one side, one on the other. In this case I have both toes aiming frontwards. See how they sit on there? Now we're going to put the glue on one of these and slide it up underneath and glue it in place. You want to make sure you don't put so much glue that it squishes off and gets into where these legs are going to move. You don't want these legs glued. They need to be able to move forward and backward. So you want to make sure that whatever glue you put in there is just a very small amount. I'm going to put a small amount out here near this outer edge. Of course, if you do get too much, you can always just try to bust the part loose and re-glue it again. Doesn't take a lot of glue because this is just a captive device. It's not load bearing or anything like that. Slide it up in there and just grab the whole assembly and kind of pinch it, or you can turn it upside down at this point, like so. Then we're going to glue the other one on. And if you don't get enough glue and the part falls off, then you can always just glue it on again. Better to have too little glue than too much glue, because you want those feet to be able to move freely so that the motor can drive them forward and backward. The weld on number 16 is pretty quick to bond. Doesn't take it very long. Okay. So, this part is a retainer ring, and we're not going to put it on yet, but I wanted to show you where it goes because it's harder to see it later. But basically you do have those 4 mounting posts in there, and you have this piece, and you can see how if this piece is fit in there, then a person could either glue it on those mounting posts or put screws into those holes in those mounting posts. But it leaves a gap between this body part and this ridge, and that's where that's going to hold the body captive as part of this whole thing, so the body can't lift away. So this secures the body on. Now these holes are where we're going to put our bearings to make the body turn easier. And in my case, I used some beads. And this piece of wire is a paper clip, and I'm going to use the paper clip as axles. So we're going to cut some little short axles that fit into those slots and drop a bead and an axle in those 4 places, and those will form the bearing for the body. The beads, I can't remember off the top of my head what size they are, so let's throw the caliper on one of them here, or 2 of them. Seem to measure about 8.24. That one is about 8 millimeters. They're not all the same. They're all at 8 or just a little bit bigger. If your bead was too big, obviously it isn't going to fit in the hole. If your bead is too small, then the body probably won't ride on it like a bearing. It'll probably get hung up. So some snips. Got a lot of kinks in this paper clip. Try to find something about the right length so it can drop down in there. I could have pre-prepped these and probably should have, but I didn't. So basically, I've got me a little piece of paper clip and the bead sitting on it. And I'm going to try to drop it in there. Oh, went right in, just like that. So now we have a bearing. And let's make another axle. Could have made this video shorter if I'd pre-prepped these. There's 2. There's 3. You can also use straight pins as axles if you don't happen to have a paper clip laying around. Whatever fits the hole in your bead and fits into the body. So, there we have it. I've got the 4 bearings sitting on there. So the next thing you're going to want to print will be the body. And in the case of this body, I've already painted it, obviously. But the body prints is one piece, sitting as you're seeing it here, and the only places that I add supports are obviously up under these claws, because you've got overhang. So I let the slicer put supports here, I let the slicer put supports along here, and I had the slicer put supports in this whole back area where the battery is already glued in. I've already glued a battery box in and put batteries in, but having the supports in there will help keep all that open and to size. The battery door prints actually vertically on the bed, like I'm holding it, no supports. So far this is the only part besides the little ratchet holes in the feet where we had supports. These, I've already mounted in a switch into this hole. This is a standard slide switch. It's about 19 millimeters hole to hole on the screws. Nothing special there. There are separate files for these 2 dial lights. I printed these in clear, translucent, and there are 3.5 millimeter holes in the back of these so that you can easily glue in LEDs if you want to illuminate yours, which I plan on illuminating this one. So as you can see, this hole in the bottom is going to fit right over the top of this body assembly. Like so. Now, what I've already glued in here, unfortunately, I shouldn't have because it would make it easier for you to understand, but you can see these 2 pronged pieces, this, and it goes along there and comes out here. That's a separate piece. It prints without supports. which I've already glued into the body, but basically I could have glued it the other side. You kind of see how there's a ridge in the body. Maybe if I reach this way you can see where my finger is. My finger's running along this ridge. That helps you slide that part down to that, and when you put the part in, I'm talking about this part, you kind of sight to the side so that you know that you've got it in line. That'll have the body facing forward and being able to turn back and forth. These two pieces are going to run on the sides of this leg. So as this leg moves back and forth, because those two parts are captive on it, that'll make the body move back and forth. The hardest part about putting this mess together at this point is this piece will be pretty hard to get in there around the motor and everything else after it's all together. So you almost kind of have to just set that part down on the bottom kind of loose down in there so it's sort of where you can get to it later. And when you set the body on, now all I have to do is reach in there and push that piece down into place. Like I say, if you were going to glue it, you'd be good to go. It wouldn't be hard to do. I'm going to screw mine on if I can find some screws over here. Once again, I should have been more prepared and had the screws ready. But we're really about at the end of showing you the mechanical part of the build, because this is where it'll be working. I'm going to use these number 2 screws to reach down there and screw that thing in place. But I don't think I'll bother to do it on camera here because it's kind of time consuming getting your fingers down in there and everything. At this point you could just take your battery that you had there and run one wire to the motor, run the other wire to the switch on the front, run a wire from the switch back to the motor. Then when you turn the switch on, the robot will walk. There's no correct way of wiring the motor. It can run in either direction and the robot will still walk forward and the body will still turn. Like I say, adding lights would be a separate detail, or sound, as I've added sound and lights to my other one. The only 2 remaining parts to the whole robot is there is a head, and again the head prints as you're seeing it here, and I did have some supports under these parts that stick out. Didn't really need any supports on the inside. This particular one I have actually added a sound module to it because I was going to have sound. And again, there are individual parts for the head, these little dome lights, and they're set up again for 3mm LEDs. I printed mine in translucent white. It's actually clear, but it comes out translucent white. And put LEDs in mine. To hold the head in place, to keep it from just dropping down in there, there is this separate cross piece which has indents where you could put glue on that, and then you would just inset this piece and glue it into place into the body, into the top of the body. And that gives the head something to rest on when you want to glue it down in there. And that is basically the build. It's a very simple mechanical build to put together if you just want to do the walking part. Of course, if you want to add the LEDs, then flashing red LEDs will work off a 3-volt supply, so you could just use flashing red LEDs throughout this and wire them direct. No problem there. I did add, and I suggest it is a good idea, I did add a decoupling cap across the motor's brushes to take any spikes, because a lot of the flashing LEDs don't like to see the noise and interference that come from the brushes of the motor. In my particular case, because I'm also going to have a sound system in it, I did add in the back here this separate voltage regulator. It's a boost regulator, so it'll take the 3 volts and boost it up to 5 volts for the sound system that I had in there. But again, these are not necessary things you need to make a walkie and body turning robot. And as long as you just use flashing red LEDs, you don't need that power supply thing either. They'll run fine off the 3 volts. So if I can get logged into Thingiverse, I will put the files up there, and I guess I'll leave a comment down below when I do get the files put up there so that you can have a link to printing these and having some fun building your own walking and body twisting robot.